So now at the end of this class, I'd like to revisit some of the original ideas we had with limits, and now looking at L'Hopital's rule, and now combining some of the new functions and some of those abilities that we have. So what I want us to first think about are indeterminate forms. So we've seen indeterminate forms in this class already, right? So we knew that 0 over 0, right? If we have a limit that gets 0 over 0, that means we have to do more work. We can't determine the limit as is. It is an indeterminate form. Another indeterminate form that we've seen a lot of is plus or minus infinity over plus or minus infinity. This one we've also seen plenty. We can use L'Hopital's rule in this case as well. Now there's some other types of indeterminate forms that maybe we mentioned briefly, but I would like to revisit and spend a little bit of time taking a look at how we deal with those. So one of them is 0 times infinity. Remember, we said that in indeterminate form, it's kind of like these two pieces are working opposite of one another. And so it seems like one's pulling it in one direction, the other one's pulling it in the other direction. So where does it fall with the limit? So we're thinking about 0 times infinity. We're thinking, well, anything times 0 should be 0. But infinity times anything should also be infinity. So how, if it's pulling towards infinity but also pulling towards 0, I don't know what the limit will be. So 0 times infinity is one of these. Infinity minus infinity is another one of these limits. Trying to subtract two things that are seemingly infinite, we don't know what the limit's going to be. Another one now is going to be, say, 1 to the infinity. If you have a number that's less than 1, if you raise it to more and more powers, that goes to 0. 1 raised to any power should always be 1. A number larger than 1 raised to larger and larger powers is going to go off to infinity. So we don't know what this one would be. We also have something like 0 raised to the 0 power. This is something that's also going to be an indeterminate form. 0 raised to any power should be 0, but also anything raised to the 0 power should be 1. Another one of our indeterminate forms would be infinity to the 0. That's another one where now if the base is getting bigger and bigger, but also the exponent is going to 0, well, anything to the 0 power should be 1. But bigger and bigger numbers seem to also be getting bigger and bigger. Okay, so these are a few more of our indeterminate forms. And so what we're going to have to do is deal with these a little bit differently, because L'Hopital's rule, as a reminder, if we have L'Hopital's rule said that you take the derivative of the top divided by the derivative of the bottom. And then you retake the limit of whatever x is going to. So this was the process of L'Hopital's rule, but in these two cases, super easy, right? You have 0 over 0, infinity over infinity, take the derivative of the top, derivative of the bottom. But what about these other cases? Now we don't have a number divided by another number. We don't have a fraction. We need to figure out how do I deal with these other instances to be able to apply L'Hopital's rule, right? How can I get fraction over fraction when you're subtracting two things, or especially these when they're exponents? How do we deal with those? So we'll do a bunch of examples of figuring out how do we deal with all of these, but in particular I'll point out that these three are going to be the highlights that you really want to take away from this, because it's going to be using some of the techniques that we've already been using with logarithmic differentiation.